Hi guys, welcome to Edustart now. Just to rehydrate, if you haven't subscribed to our channel, please do it. And if you have any doubts, please mention the doubts in the comment box below. I will respond as soon as possible. And I would like to inform you guys, we are also on Instagram. Please do follow as EduTrust now. Okay, so let's begin today's show. Okay, so we'll go with yesterday's. We'll brush up whatever the topics which I've covered yesterday. And yesterday we have covered the weighted mean and formula for weighted mean, and we also covered the dispersion measures. What are the dispersion measures? Okay, and what are the quartiles and interquartiles? What is the population and the variance for that? And we also learned how to measure the variance and comparing the standard deviation. Which one is higher and which one is lower? We also learned what is Z score and symmetric or the shape of the distribution exactly whether it is left side skewed symmetric or right side skewed and quartile measures. Okay, and we have taken an example and things like that, and we have also understand what was the concept of population and sampling and how the sampling distribution can be helped, and measurement of the character features of a shape of the distribution, whether how and when this can be used. We also focused on what is population and the sample, and we have understood what was exactly sample and when sampling should be used. So these are the topics which we covered, so we'll continue from here. The concepts of non-probability sampling, and today's topic is a very important topic where we'll try to jot down the important points of statistics, and what is inferential statistic that plays a very important role in the future. So that is also quite interesting. Which one? The conceptual knowledge of the business statistics. So how business statistics plays an important role in the current scenario, and things like that. So we'll continue today's session. Today's session will start from non-probability sampling. So in the non-probability sampling, we also what jotted down in four parameters like accidental sampling, quota sampling, judgmental sampling, and the snowball sampling. So these are all the one. So yesterday we also discussed and described and tried to distinguish what exactly if you would have taken a sample of say Android developing app. Okay, and we tried to give it to the three friends, and before releasing it to the market, we just wanted to know what is the exact feedback of the app currently present in the market. Just to take that survey, these are the methods of sampling like accidental or convenience. So this type of sampling is nothing but just targeting the few people in the market, whom whatever or whoever which falls in your eye, you just directly go near him and ask them whether this we are conducting a survey and we are from so and so department, please kindly help me out in filling up this survey. This is accidental, that means convenience. Okay, judgmental, target only for the college students. So obviously the app or the younger generation, say suppose if you go and ask a 60-year-old man, so he would have been not much comfortable in explaining and giving his 100% genuinity and 100% knowledge regarding that app. So say suppose if you're a college student, if you're given this thing, he would have been explained in a very good manner, right? So quota sampling, say suppose it's just as a judgmental sampling, it is dividing the quota of three men. That means if say suppose I'm given an opportunity or given a task to complete the survey, so I would like to prefer to do on three men and one woman. So that is the amount of judgmental and quota sampling which I would do. Next is the snowball sampling, which I love the most. My personal opinion, this is one is very good among all the sampling, which is my opinion. I'm not that is my personal opinion which I'm giving you right now. So focus on getting people who fill the form, and also giving them the trial version of it. Say suppose if I'm launching a shampoo, I will give the shampoo sachet to try them. Okay, to try them and then give us a feedback. I know it's an additional expenditure which we are incurring by giving up, or else we are that's an additional expenses for the company or the product, but it gives 100% feedback is what personally I feel. So this is all about the snowball sampling. So next comes on systematic sampling. This also we have covered yesterday. Random sampling we have covered, advantages and disadvantages we have spoken, and just this was an example where we have not much focused. I have received some comments stating that kindly explain these sampling methods regarding this thing. So regarding what are the examples and where and when practically the sampling methods are used. So that's the reason I'm reiterating once again. Cool. Okay. So let us understand much more probability sampling, like when stratified random sampling is used, when systematic sampling is used, when this SRS, when the SRS sampling is used, and when the cluster sampling is used. So first we take there are sampling methods. So SRS is a sampling where a random number is assigned to the each student. Okay, from 1 to 1,000. Say suppose in a class they are from 1 to 1,000 members in a school. If we take, so so randomly any number you select, like 56, 57, and 70, and then take the sample of that, then collect the sample of that is SRS sampling. Now the systematic sampling is, the word systematic itself is describing as we are going in a particular pattern, that every 10th student in the database is selected as a sample, like 10th, 20th, 30th, 40th, 50th, and followed by satisfied random sampling. Students here, if we are suppose we are trying to select some students, so what we are doing, we are selecting we are combining the whole population of the school is converted into a compiled students. So from that we are selecting a random student, so that we'll get a bigger picture and understand better what are the consequences of a stratified random sampling. Cool. Next, cluster sampling. These are nothing but we are forming in certain groups. This plays a very important, guys. Please pay careful attention regarding cluster sampling. So cluster sampling is the one where the students are divided into groups, and the samples are selected from each cluster, and then this cluster is gonna represent the population. Hope we are sticking to that. Okay, this is a wonderful example. By this you can easily able to recollect. And if you say suppose in interview question, there might be straight away question, what is SRS, can you explain what is cluster sampling? So these examples are the way where we can remember easily the concept and try to explain the interviewer and try to get a job. Okay, so now this also plays an important role. So please play please pay highly attention in this thing, and please make a note of what are the errors in the data collection. Okay, so let us start. So total errors have been broadly divided and classified into two types, that is a random sampling error and non-sampling error. Okay, random sampling error we will discuss in the coming up classes. That means coming up slides. So coming up classes we have to focus much more on non-sampling error rather than random sampling error, because this has a very what key important role, and it has a very large, very wage area. It's too huge. Okay. So non-sampling error is divided into two types. Those are non-responsive error and non-responsive error and a response error. So research errors like interviewer, so response error are those which form research errors. Okay, research errors, interviewer errors, and respond errors. So first one, research error. So research errors are those which segregate the information error. Okay, measurement of error, population definition error, sampling fair error, and data analysis error. So they might be segregating information error, so they might be collection of many number of errors, right? So they'll be collecting from the clusters form, they're collecting from SRS, they're collecting from stratified random sampling, they are taking so a number of methods they are using, they're segregating the information. They might be they might be undergoing an error in they are undergoing error in collection of the data. So measurement error, so suppose one cluster have been taken in terms of kilograms, and one cluster has been taken in terms of grams. So there might be error in the measurement, right? So that is also, that might be one of the reason. So what is a population defined error? The entire population might be error. So we are focusing on the what we are focusing on one topic and they are addressing on another one. Sampling frame error. That means any frame or any data frame which we try to connect or that time that might be error. And another important aspect is data analysis error. So after collecting the data also, we should be crystal clear what are the analysis which we do. Because the data is trying to speak other and we try to understand in another direction, then entirely the research and the errors which we try to collect in the data collection, that might be 100% error. So this is an important error and highly amount in my personal experience and at my workplace also. I feel highest amount of data errors which I feel is an interviewer error. So responded selection error, entirely responded whatever the things which have responded selected is an error by interviewer. Okay, questioning error. That means a question. I asked you a question X. So you thought it is a Y and you try to express the answer of for Z. Okay, that might be a questioning error. So recording error. So whatever the answer which you have given in the form of Z, I try to write it as A. Cool. So that might be one of the error like recording error and cheat fund error and things like that. And next is inability error. That is so responded wantedly they wanted to do, or else they really the one who's taking interview he has doesn't have any interest in making up notes. So that is a will issue exactly. An unwilling error. That means certain errors are there which we can't avoid it. They are in nature. We'll try to discuss what are the things and what are the subjects which we have will learn in coming up sessions. Okay, so minimizing. So the overall concept of errors are to minimize the error. So our main job is to reduce the errors. So sampling errors to ensure that the sample selection is chosen as a representative. So sampling errors. So whoever is representing an error, right? So whoever is representing error and whoever is collecting the data should make ensure that whatever the sample which is selecting that should represent the overall population. So he should be trained properly and he should keep in his mind stating that what are the sample sections and what are the sample he has chosen as a representative, he has to take care of that. So non-sampling, these are the non-sampling errors with clear definition of measure ensure there is no ambiguity in understanding the objectives of sampling. So the one who is making a note of it, he should be crystal clear in understanding what are the objectives of the sampling. So next, train the interviewer in collection of the data process. So make him train him as soon as possible and what are the data which is collected. Call back if possible to eliminate non-responses. So if there is any non-responsive from the people, try to call back. If you don't understand him, try to again ask and correct and capture the genuine error so that the risk in minimizing error would be less. Check data checks to ensure that there is no error in the data capture. Okay, these are the important things which we have to pay much more concentrate level. This is a very advanced level which we are getting entering into, so please pay much more attention it. So sorry for that. So now we are entering into the what is confidence level, degree of freedom and p value, that is a probability value. So these all are items which comes and which directly reflects under sampling. Okay, so say suppose if I'm selected a sample from the probability and we try to do whatever and we try to inject and try to understand what are the confidence level in measuring the confidence level of a hypothesis. Okay, then what is level of confidence? For example, I have selected an hypothesis and data and I'm giving you an assurance that 98% I am confident that this data is showing so much accuracy out of that sample. That is confidence level. Degree of freedom is the total number of options which I do have while selecting the data is a degree of freedom. P value, that is a probability. Okay, probability of happening or non happening a future event. Okay, any event. An extreme is observed assuming that the null hypothesis is tested. null hypothesis is tested, and whatever the null hypothesis is tested is basically true. So I can just read these slides, but I am explaining you in a very simple manner, and now we will jot it down. What is confidence level with an example, and try to understand the concept of confidence level, degree of freedom, and p value. Okay, that is a specialty of Edustart now. So, what is confidence level? It describes the reliability of an estimate. So, already we have explained, right? So, 98% I am confident. That means how 98% I am reliable to this hypothesis, stating that we are very much confident with that. So, range of values, lower and upper boundaries. Okay, the lower and upper boundaries of the population should be included. That is a level of the confidence, right? Lower range is nothing but we already discussed what is range. It's nothing but max minus min is a range. So now the confidence level, the probability associated with the confidence level interval. So this is a confidence interval. That means how much percentage it is. This is a level. So at what level you can stretch yourself. That is all about the confidence level and confidence interval. Now we come on to degrees of freedom. So degrees of freedom is a measures the number of values in a study. I'll explain briefly, then we'll read it up what exactly this slide wanted to explain us. Okay, so say suppose you have 10 cars. You have 10 cars, and you want to rent one car. Okay, among this 10. So if I say suppose X guy came and he had opted one car, so there are remaining only 9 cars left over. Okay, so 9 cars are left over. So remaining 9 cars are left over. The degree of freedom is 9. Another guy Z Y, he came and took the car, and then 8 cars are only left over. Then the degree of freedom is 8. And next thing is the so one car here took another guy came, another came and took another car, and there are only 6 degrees of freedom or present to them. Okay, so I'm thinking about why can't we give another example for how apart from these cars. Okay, first we'll understand, then we'll think over it. So now the degrees of freedom are only 8 cars is left over. So how much time and how much options which are left over are the degrees of freedom. So in the practical world, in the practical example, this is directly related as say suppose if you have a say suppose you have a column of mean. So if you're selecting one row of that mean, and your the degrees of freedom of losing the confidence level also affects with the selection of degree of freedom. So if you eliminate one, the confidence level might be increase or decrease. If you eliminate two, it might increase or decrease. That depends upon the scenario. So degrees of freedom plays an important role. That exactly I wanted to say. Okay, so the next topic is p-value. P-value is a probability value of obtaining a test statistic at least as an extreme as the one that was actually observed, assuming that the null hypothesis is true. So first, to understand this line and this sentence, you have to have the proper knowledge about what exactly the hypothesis and null hypothesis is, and what is null hypothesis, what is alternate null hypothesis, what is hypothesis testing, and things like that. So when p-value is certain level, significance level, often 0.5, often level, that means a maximum level, you'll reject the null hypothesis. This results indicates that the observed result is not due to random occurrence, but it exactly and a true difference. So let us understand why the p-value will plays an important role, and what is null hypothesis, and what is where the hypothesis is exactly used, and what exactly the p-values and where the p-values lies, and what are the two mutual events when given a scenario. Okay, then this follows. Okay, so what exactly is hypothesis? So hypothesis is nothing but it's an assumption which we make about a population parameter. I would like to give an example. Say suppose there is a x number of population present in place in an area, and we try to make a sample out of it. So that is an assumption which we are making. Okay, that is an assumption we are making that would have been represent the entire population. That is hypothesis. So the hypothesis which we wish to test is called null hypothesis. So whatever the exam sample which we have taken, okay, I would like to give a wonderful example which my sir taught me. That is like, it's good. It goes like this. So hypothesis assumption. Okay. Say suppose in an area there are 10,000 people, and we want to know, we want to calculate the population. What are the how many people are there in that specific area? I'm giving you an answer that is 10,000 people. Okay. So say suppose if you don't know, what in case if you don't know the answer is 10,000, then what we're gonna do? So we're gonna take a sample. We're gonna take a sample of that entire population in that 1 square feet. How many people are there? Okay. So that sample is known as null hypothesis, because that samples are going to represent the entire population, right? So that is a null hypothesis which we are trying to explain and trying to get through. So this is because there is no difference, because there should be no difference between the population, and as well as there should be no difference between the population and the sample. Okay, it should represent technically. So that I exactly wanted to say. Next, the thesis is something which has been proved to be true. However, a hypothesis is something that has not yet been proved to be true. So thesis, that means I would like to give an example. Say suppose thesis of a anatomy of a human body. These are the theses which have been given in the subject of anatomy of a human body, where you have five sense organs, you have eyes, nose, ears, tongue, and skin. So these are the theses which have given. That means it is a complete given proof that you have this thing. However, hypothesis is something that it has not yet been proved. Null hypothesis, in other way. If you're talking about hypothesis, that means null hypothesis, because it has to be proven, proof, because it has not yet proved. So that is overall concept of thesis, hypothesis, null hypothesis, and hypothesis. Guys, once again, I am reiterating, I am giving you a wonderful opportunity. If you have any doubt, if I'm not clear, if you want to give any feedback to me, please feel free to comment in the comment box. Your feedback is highly appreciated, and I'll try to improve. I'll come up with another. If you have any doubts, indeed, you please try and to comment in the comment box, so that I can make a better videos and come up with a new subject knowledge. Okay. So, and if you like this video, please press like button. Okay. So now let us continue. So hypothesis testing is a process of determining whether or not a given hypothesis is true. So overall job of us is to collect the sample. Okay, collect that sample and try to project, determine whether the hypothesis is true or false. Okay, hypothesis testing along with estimation forms the foundation of interferential statistics. So interferential statistics is, the concept of this is a complex thing, whatever the complex thing with a proper evidence and fact. Okay, is called inferential statistics. Okay, plays an important, please play much more concentration. Much more attention is required for what is inferential statistic. That might be a straight away interview question. Can you please explain and elaborate what is inferential statistics? So please make a note of thing what are the interview questions which I'm gonna stressing out. That might be straight away gonna ask by interviewer in an interview. So that plays an important role. Okay, so that the hypothesis testing with an estimation, that means say suppose if you're trying to estimate some hypothesis value, and on the top of it again, you have some proofs to proof stating that this is the thesis which the outcome has up to. So that is inferential statistics. Okay, if you have any doubt, please once again, I would like to uh, explain you via comment box, so please comment it if anything is required. So first steps in hypothesis testing is to normalize. The first step of hypothesis testing is to formalize it by specifying its the null hypothesis. So the first step in hypothesis testing is to formalize it by specifying the null hypothesis. So before calculating what is a null hypothesis, your job is to specify. The job is to specify What is the exact sample you want you what is the exact sample which you want to test on it. So that is null hypothesis. So next slide is, a null hypothesis is an asset is a representation. Guys, if I read the slide that doesn't make any sense, first I'll try to explain and then we'll try to read it and then try to understand what exactly the sentence and the statement and slide is try to explain us. So null hypothesis is is a value, okay, is a population parameter, okay. So from that, we'll go back to that example. So we have collected the entire parameter, okay. We have collected that entire population and that we have converted it to population, and from that population we have converted into sample, and that sample we treated as an hypothesis, and that hypothesis is treated as a null hypothesis, and that parameter should hold the sufficient evidence to state that whatever the sample which we are collect is representing the whole total population. That is null hypothesis. So otherwise, if you don't have null hypothesis, then we'll reject it. If we are having enough sufficient to prove that whatever the things which we are doing is a proper format, which is in a proper format, then it is nothing but it is a sufficient enough, we have sufficient enough to conclude. Okay, you got that. It's a simple phenomena. So that is null hypothesis. And if we reject, right, then that is an alternative null hypothesis. Simple. It's a very simple. You remember this example, place it to copy paste in your mind. If the interviewer question is going to ask you whatever it might be, null hypothesis, alternate null hypothesis, what is hypothesis testing, what is thesis, why, when thesis is going to play important role, why, what is a hypothesis, where exactly we use hypothesis in the practical scenario, you should be able to tell on your fingertips. Okay, these all should be in your fingertips. Okay, chalo buddy, let's go. So according to R.A. Fisher, he is a statistician to for further info for the further FII. Hypothesis testing is possible rejection under the assumption that it is called null hypothesis if it is true. Okay, if it is true, underline this thing. So hypothesis is possible rejection. Hypothesis can be rejected only under the assumption that it is true, then we'll reject. Okay, the rejected null hypothesis is called the hypothesis which is yet to be tested. It's a bit tricky, it's a bit confusion, but with the further examples in another slides we're going to understand better what exactly the hypothesis wanted to what exactly the hypothesis wanted to explain us. Okay, it is denoted with H naught O, or it's HO. Okay, the alternate hypothesis is a negation of the null hypothesis. I already informed you, if we are rejecting any null hypothesis, then it is an alternate hypothesis. It is nothing but we have we have rejected that. That means that sample doesn't fit that population. That is alternate hypothesis. It is denoted with H1 symbol. Clear? The And next topic is, because the null and alternate hypothesis are the exact opposite statement, only one of them can be true. Rejecting one is equivalent to accepting the other. Simple. Because of the null hypothesis, if we wanted to select, if we say, suppose if I'm selecting one object and rejecting another, that rejecting another means that is obviously false. If the statement is true, that means the other statement is false, right? If we are having only either option to select true or false. So similar way, just confusing, but it's very easy if you understand the concept. These are the overall concept of hypothesis and null hypothesis. But the question is, how does one formulate hypothesis? There is no hard and fast rule. Okay, it's a question that how can you say, buddy? Say, suppose if I'm giving a population and if I'm asking you to find it out which is a proper example, which is a proper state that 100% true that this gonna be, the 100% is gonna be whatever the amount you selected is true. So we can't judge like that, right? There is no harsh and fast rule. You can select whatever you according to that scenario you feel you have to select it. So very often the phenomena under study will suggest you the nature of null and alternate hypothesis. So depending upon the situation, buddy. That's simple. That depends upon the situation and alternate hypothesis and null hypothesis. You have to make a call. That is the role of a data scientist, where the data analytics plays an important role in this thing. So theoretical expectations on the empirical work both can be replied upon the formula of hypothesis. And now the very important topic we call as evidence collection. So af- evidence collection after the null and alternate hypothesis are spelled out, the next step is to gather the evidence. Null hypothesis and alternate hypothesis are spelled out, the next step is to gather evidence. So after understanding the concept of null hypothesis and evidence collection, the next step is to gather what are the evidence which have been we have collected. So the best evidence is that where you are 100% confident in that. That rarely and technically happens, but try for the level best is what we can say. So in all cases, evidence is gathered from a random sample of the population. That means in any population, if you want to collect the confident, excuse me, in him. So whatever the evidence which we gather, that would be in any random thing from that population should be okay. So an important limitation of making inference from the sample data is that we cannot be 100% confident about it. Okay, cool. So next, these are the one important thing: the type one and type two error. So in a professional or personal life, we often make a decisions like accept or reject. That decision based on based on incomplete data. So A, the quality control inspector has to accept or reject the supplier of a vendor, usually based on the sample. Okay, say suppose you have a hotel and there is a vendor which gonna come and meet you. Um, so there's a vendor who gonna come and check whatever the samples whichever he have sent. So he'll just check the sample of it and he has option to reject or accept. Only depending upon the basis of the sample. So he doesn't have the option to complete entirely check everything and whether has to make a call on whether accept or reject. So he has only sample basis. And based on the sample, you have to make a call. Same goes with the recruiter of a interviewer. Also, he'll read your resume, and depending upon the quality of the resume, also he gonna make a call whether to give you a job or not. So I request you guys to subscribe this channel because we'll go through how to make a resume and how to impress an interviewer in an interview. So okay, so stay tuned. So as long as our decisions are made on the basis of evidence that does not provide 100% confidence, there will be a chances for error. So if there is a chance if there is a chance that 100% of the data is not at all confident, so there will be a chance for an error. So no error is committed when the good prospect is accepted or a bad is rejected, but there is a small change that the bad prospects is accepted or good is rejected. It may be so it may be any given scenario whether it might be selected or rejected. If the selected one might be a bad one or else the bad one might be the good one. So that depends upon the situation and also the times give the correct answer for that. So researchers has to minimize the chances of such a so whoever is accepting or trying to select the thing, so should be very careful in the selection of this thing. So next very important role we are trying to discuss, and that is systematic relationship between a pair of random variables wherein a change in one variable reciprocated by an equivalent change in other variable. So covariance plays a very important, guys. So let us understand first the what is the formula, that is COV is x of y given x minus x mean into y minus y mean divided by n minus 1. So this is a covariance formula. So covariance is nothing but which is an reciprocate by an equivalent change in another value. That means is like to give an example where have two parameters like height and width. So whatever the weight has directly proportion to their height. So increase in height may also have equivalent reciprocate to increase in weight. So that is this statement is trying to explain us. So covariance can take any values between plus sigma to minus sigma, where infinity can also, we can also call as at an infinity, whereas so it can be lead to any other and it doesn't have the unit of measure. Okay. So whereas a negative relationship is where when we have the positive, negative relationship is when the negative sigma is treated as a negative relation and the positive sigma is treated as a positive relation. That means there is a relationship if it is a positive. If it is negative means there is no relation. That's an implied meaning. So in addition to this, where all the observations of either value are same or covariance will be zero. So it might be same or it might be zero. So when we change the unit of observation of any or both of the two, there is no change in the strength of the relation between the two values, but the covariations obviously change. So it might be height, weight, and color. So height may directly impact the variable on weight, but the color doesn't play any effect doesn't pay any effect on weight. Okay. So that is all the explanation about covariance. So covariance also plays an important role, buddy. So now let us understand. So let me describe on the very first note what is the negative effect of covariance. So covariance is nothing but it doesn't have the exact values of minus. It doesn't give the exact value of how much percentage the variance is. So what is the exact percentage? That means 10%, 100%. What is the exact variance? So to get the exact value of the covariance, correlation comes into the picture, where it gives the exact picture of what is exactly the correlation between the two variables. So formula is here. It's stating as us correlation of x comma y is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y is a correlation. So it measures the variable change in one unit due to change in the other variable. So just like sales of ice cream is higher or it is increased in summer than winter. So increase in one variable like temperature increases, the sales increases. The price also might be increases. So that is a correlation between both of them. So here also we have types of correlations like positive correlations and negative correlation, where positive correlation, if we put in a type of a graph, it is a right side, it towards right side. With the negative correlation, it's towards left towards the y-axis. And there is no, if there is a data is in terms of a scattered diagram, that means scattered plots, then it is have then we can significantly say that there is no relation. Okay. So these are the four types of measurements of the measures of correlation. They are the scattered diagram, product movement correlation coefficient, rank correlation, that is also known as Spearman rank correlation, that is a very important among all. So coefficient of the concurrent deviations also, which will give the exact amount of how much deviation is associated for each and every correlation. So that is a part of the correlation. Now let us understand what is the exact difference between covariance and correlation. So meaning covariance is a measure of indicating to extent whether two random variables change in tandem. So what is amount of change in a particular covariance, we'll get to understand in this thing where x and y is given. So we'll get to know what is the exact whether there is a relationship exist between covariance of x and y. So correlation is, it gives a strong variables, it can give you strong scaled version of covariance, how two variables are interrelated to each other. That is correlation. So what is it? So measures of correlation, it is obviously the measure of a correlation, and it is a scaled version of correlation we already discussed. So the values lies between for covariance lies between minus infinity to plus infinity. It may go from anything, so it may vary from any version. And whereas hold on for a second, and for the whereas it for correlation lies between 1 -1 and +1. So change in scale, it affects the covariance and it does not affect the correlation in changing scale when the matter comes to correlation. Unit free measure in covariations no, whereas correlation it is a unit free measure. We can easily calculate and get to know what exactly the correlation was. So let us understand the summary. This is the climax part of the correlation, where we can exactly try to understand what is correlation in a special case of a correlation, where we can obtain the data when the data is standardized. So data is standardized only, then we can able to understand the concept of correlation. But when the matter comes to choice making and preferencing between the preferring and comparing between the two pair variables, we prefer correlation. Okay, that's a summary of correlation and covariance. So correlation and regression plays a very important role, buddy. So in the long run, we'll discuss what exactly the regression when we start the DM, that is the DL, that is machine learning and deep learning. So that time we'll discuss what exactly the regression analysis and things like that. Now let us understand the concept of central limit theorem. So central limit theorem, the formula goes like this. That is standard deviation is equal to sigma of x is equal to sigma divided by root of n. So that is a central limit formula. So let us understand what is the concept of central limit theorem, where we have entire population exist over there and we have the parameter sampling and statistics. So we have the sampling distribution for that too. Okay, so from this entire population we have collected the samples. So from that sample we have n number of objects, that is n present over here, and we have the sample variance also. That is we have the sample variance, that is we will try to calculate what exactly the mean of this sample of individual samples. We try to collect that, and we try to plot that graph. It's gonna be in the form of a bell shape, or else if you go for a histogram like this. So the one point of sampling is this thing, another part of the sample, if you go for histogram, median lies here, the midpoint, and the midpoint for this thing is lies here, this thing lies here, this one here, this one is here. So if we try to collate everything and try to put a so excuse me, so we try to put it in a single format. So that comes around and sits in a form of a bell-shaped curve, and exactly the sample distribution lies the central of the median of this graph. So where we can easily able to understand what exactly the concept of central limit theorem is been introduced and introduced. So we'll get to know what exactly the exact point of the various what exactly the various amount of enter points, the midpoints which have been taken into the consideration is all about the central limit theorem. Okay, cool. Let us understand the concept of empirical rule. So empirical rule approximates the variation of the data in the bell-shaped distribution. So approximately, basically from 68% of the data which is in bell shape falls under empirical rule. That is the summation, that means union of plus or minus 1 sigma is a value. So the u is a population, that is a capital population. That means 68% of the data is in bell shape, and next approximate 98% of the data which 95% of the data which lies in yeah, sigma plus 2 sigma, and 98% of the data which lies in this. So depending upon these parameters we can easily make it out what exactly the empirical rule states into. So suppose I would like to give an example. Say suppose there are 500 people which are existing in that. So, and if you want to if you want to get the empirical rule of that statement, it gonna visualize like this. So entire 100% of the data, 68% of the data lives in the first quadrant, and 95% of the data lies in the second quadrant, and third quadrant 99% to 99.7% of data falls on the third quadrant. So apart from this, they are known as outliers. We already discussed yesterday. So this is all about the empirical rule. So we'll in the coming up classes we'll get to know what and when empirical rules are, when empirical rule is useful in the real life scenario and practicality, so that we can able to understand what exactly the empirical rule talks about. So now let us understand what is a normal curve or a bell curve. So normal distribution means when the mean is 0 and the standard deviation is 1 is known as a normal distribution. It is also known as a standard normal distribution. Where the mean is 0, that means the mean is exact midpoint and the standard deviation is 1, then the normal curve is in bell curve. And that formula we have to substitute by 1 by root of 2, whereas pi into e to the power of minus u minus x whole square divided by 2 into sigma, the standard deviation or variance square. Okay, so that is the exact for normal distribution. We'll elaborate in the coming up classes what exactly the normal distribution, when to use and where to use. So let us understand by the way of small examples and things like that. So distribution of symmetric peaking at the mean with the probability distribution decreasing away and after this mean smoothly. So the spread of a normal distribution is controlled by standard deviation. Smaller standard deviation data is concentrated near the mean. So mean is equal to median in normal distribution because mean is 0. So example, height of a student in a school, incomes of a families in a society, in a city, and things like that. So these are the better examples for normal distribution. So let us understand Euclidean distance and Manhattan distance. So it's nothing but let us explain. I'll explain through a graph. Okay, so what exactly the Euclidean distance is talking all about when the matter comes to this. So let us assume we'll draw an x and y axis and x axis, and we try to plot a triangle, and that is a hypotenuse right angle triangle where this is 90 degrees. Okay, this is 90 degrees and this is A and this is B. Okay, my writing might be bad. I'm using a laptop cursor to take care of this thing. And so this is a triangle. This is x-axis and this is y-axis. We know, or everybody known that, everybody's known too for. And this is x-axis. Okay, and this is a y-axis. If we come to, okay. So and if we want to calculate the distance, we'll have a formula to that, where AC square is equal to AB square. Sorry, let visualize this thing as AB square plus BC square. Okay, so AC square, it can also be written as AC square can also be written as root of AB square plus BC square. So if you want to calculate the exact distance about what exactly the Euclidean distance is talking all about, so this is complete distance. This is x-axis point and this is a y-axis end point. So if we try to subtract this point and subtract y part from this triangle and x part from this triangle, we'll get x1 and x2. This is y1 and y2. So by this we can easily able to understand what exactly the formula goes well. So by this we can get to know the distance between, if we subtract x2 minus y2. So y2 minus y1, x2 minus x1. We get to know exact the distance of that, or else we can calculate this thing and try to substitute and get AC square distance between AC and C. Then you'll have equivalent distance. Then we have equivalent distance, and it is also known as Manhattan. This is known as Euclidean distance. So the formula for that is x2 minus x1. Okay, x2 minus x1. where it is treated as x2 minus x1 plus y2 minus y1 whole square. So this is the formula for the Euclidean distance, where you can get to know the exact terminology of what this Euclidean distance is already expecting about. So we get to know about what is the formula. The formula is square root of x2 minus x1 plus y2 minus y1 is a Euclidean distance. And now let us understand what is the concept of Manhattan. What is the concept of Manhattan distribution? So same similar goes with the Manhattan distance, Manhattan. So I guess I would have included some theory and stuff like that. Manhattan distance. So Manhattan distance is nothing but, as we all know, that equivalent distance is the formula for it is a root of x2 minus x1 or y2 minus y1. We already discussed over there. So the next part is it's a modulus of x2 minus x1 plus y2 minus y1. So this is the exact formula for that. So what is the exact difference between Euclidean distance and Manhattan distance is, say, Euclidean distance we can get a negative terminology. If we try to if we do the square root of x2 minus x1, we may land up in doing by negative numbers also we can land up. And as in Manhattan distance we can we have using modulus, that is it should be plus or minus 1, but if it is negative also we treat it as 1. That means to get the most accurate distance we use Manhattan distance. So that's it guys for the today's session. We have discussed till Manhattan, and if you haven't subscribed to the channel yet, please do subscribe to this channel. And if you have any doubts, please do comment in the text below, and we'll respond as soon as possible. And thank you guys. Good night. So before ending of the session, let us give you an overview of tomorrow's topic, where it's gonna be what are the understanding of a machine learning and why machine learning plays an important role in the current scenario. So machine learning followed by deep learning, and you have AI and NLP also taking care for, and computer vision also we're gonna cover. So these are the few topics which gonna be discussed in the coming up sessions. So let us do one thing, subscribe to my channel and wait for the better content. And if once again we have a if you haven't followed on Instagram, please do follow. We are at we have Insta at the rate Edustart now. So thank you guys, thank you for all, thank you for love and support. Good night, bye bye, take care.